Hi guys, and welcome to Learn Extra Live. Grade 12s, finally it's your turn, and it is physics, just in case. I was actually trying to remind myself, what day is it again? Who's standing next to me again? It's Tracy, right? No, it's Phil. How are you, Phil?
I'm great, thanks. And what we're going to be doing today is a little bit of physics revision for those grade 12s. I hope that the grade 12s were actually watching the grade 11 show, because remember, that stuff is examinable in paper 1. And a lot of you have actually posted on the page that you're busy writing at the moment, so this lesson's for you. A little bit of physics revision.
Yeah, and guys, I know this is all very exciting, but grade 12s, Phil has a challenge question for you too, which we will be posting onto the page. So Phil, you want to take your spot at the
Absolutely.
at the board, and I'll do my little chat. Guys, don't forget to keep chatting to us on facebook.com/learnextra. Also chat to us on Twitter @learnextra. We'll be going through all of your questions in the last 15 minutes of the show. And as usual with Phil, we'll be posting lots of the content that we will be speaking about on the Facebook page. Please make sure with your cell phones that you download it, share it with your friends, keep checking back to it. You know, this is your year. This is 2012 is the year you'll be finishing matric, and let's get all the hard work in now, and let's make it easier for prelims and finals. So without further ado, Phil, take it away.
Thanks so much, Indy. Okay, well, today is a little bit of a short lesson, and most of you guys have actually managed to figure out that an hour goes by very, very quickly when we're on TV. And I wanted to start with the sections of physics which are bound to be in all of your exams. Now, every school is following a slightly different scheme of work, so I've chosen the two pieces which you should actually be mostly done with. A lot of this is covered in the grade 11 content, and some of it has been changed to grade 12 content, so I'm going to get through as much as I can. I'm going to be placing most of my physics on these two little bits and pieces today, because they are actually some of the hardest sections inside your paper, and together they can make up as much as 70% of your paper. So when you start taking a look at mechanics and kinematics, that's the grade 10 and 11 stuff, and electrodynamics. So what we're going to do is mechanics on its own. I'm going to be taking a look at a little bit of momentum, impulse, change of momentum, conservation momentum, and the kinematics, I'm going to be talking about graphs of motion. Okay. Graphs of motion, probably one of the sections which is most likely to come up as one of the first two questions in your papers. I've taken a look at the last few final papers, and kinematics, those graphs of motions, are always inside there. If we get a little bit of time towards the end, a little bit of electrodynamics, but I see that Bruce has been doing a little bit of that before me, and I'm hoping that I get through to a few questions and give you a few study tips to do with that. But what I'm going to ask Indy to do is, I'm actually going to ask you to post a challenge question. I hope that you're ready, pen and pencil, ready in hand with a calculator. Remember that the first person to answer is going to get that wonderful calculator from us, and we're going to be giving that away to the first person who can give us a correct answer with an explanation, please, because we're trying to help each other and learn extra. Now, the problem is that a lot of people are just guessing these answers, as we've noticed before. So you've got to post the correct answer with an explanation and how you got there, please, because then we're going to single you out, send you that calculator, and obviously everyone's going to go take a look at your answer. Okay, so let's put up that challenge question. Let's see what that is, and let's get right into it. It is a physics challenge. Now, there is a bit of a trick to this one. Now, what I'm going to ask my producer to do is actually to put this up on your screen so that you can see this. So I'm going to read this through, and there's some important information which I'm going to highlight as we go. Okay, so now, first of all, I've got a tank which is moving forward at 1 meter per second. Okay, now this was taken from an old textbook, so we're still meters/seconds. Fires a shell at 600 meters per second forward. The tank has a mass of 2,000 kilograms, and the shell a mass of 10 kilograms. So what I'm going to ask us to do is to find out what the final velocity of the tank is. Short but sweet, and I want to see if you can figure out what is going on in terms of these answers. Now, I want the final velocity of the tank, so let's try to find out what we need to pay attention to. Okay, first of all, let's take a look at the information. I'm going to highlight it for you, then I'm going to leave you to try to solve it on your own. First of all, I've got this tank, which is the first object which I see, and let's just highlight that. There we go. There we go. We can't highlight in black. There we go. Let's make it nice and visible. 1 meter per second is the first velocity which I'm given, and then there is another velocity which I'm given. You need to decide what to do with that, and that is a shell or a bullet. So this is just like a cannonball which is being fired forward at 600 meters per second. Then I've got a tank which has got a mass of 2,000 kilograms, and the shell is around about 10 kilograms. So now I want you to figure out how fast the tank is driving after this has all happened. Okay, so a few options. Well, the first option is that the tank doesn't change its velocity at all. It's the same because it is a much larger object, or 2 meters per second backwards, or 2 meters per second forward, or the tank has stopped. So these are your options, A, B, C, or D. Now I want you guys to be calculating. I'm sure that you are furiously calculating already, taking a look at the Facebook page and making your comments on these. We're going to come back to this once I've actually taken you through some of the approaches to this. Okay, so most of you have managed to figure out which part of mechanics this actually fits into. I'm not going to tell you anymore. I'm going to be dropping hints as the show goes on. Okay, so now that that is up on the page, I'm just going to check with Indy. Is that up?
It is up indeed, full.
Okay, fantastic. Okay, so Indy has put it up on the Facebook page. Comment on there, give your answers, and I want you guys to discuss this, please, because this has got a particular trick to it. Okay. Before we get into physics, mechanics, and kinematics, I just want to outline some of the major challenges that you'll face when you go through these sections. Okay, mechanics and kinematics, I've added up the marks in quite a few of your past papers, and that section on its own is up to 40% of your paper. Now, the reason that it's so large is because it's fundamental physics. It's talking about forces, it's talking about motion, it's talking about all the stuff which you learned in grade 10 and 11 inside mechanics. When you were doing equations of motion, when you were doing energy, it's a very, very large chunk of your exam. Okay, but now, is there any particular set of things which I need to pay attention to? Well, I'm going to give you a few tips. Okay, so when I start approaching a mechanics problem, so anything to do with motion, collisions, energy, work, energy, power, it doesn't matter. There seems to be a way to approach all of them. And what I'm going to do is I'm going to outline these basic steps to try and understand how I should approach these. The most common complaint that I hear from matrics, grade 11s and grade 12s, okay, is that people really struggle with where to start. How do I know where to start? Now, these steps are just designed to simplify things. Now, the first and most important thing, I know myself and Tracy are always saying this, and Bruce as well, always deal with a diagram. You've got to draw a diagram. You've got to be able to visualize what is going on in front of you. Now, a lot of people say, okay, well, most times a diagram does not get you any marks. But please, a little simple diagram, you'll see me drawing little stick figures and going a little bit crazy with stick men on the show. It's absolutely vital that you do draw a diagram. Get yourself graphic so that you can actually see what's going on in front of you. Okay, next in line, choosing yourself a positive direction. Absolutely vitally important for you, for your examiner, to see which direction you've chosen as positive. Now, please make sure that you don't make yourself any rules like, okay, well, this is always going to be positive. That's not always going to be the case. Sometimes your examiner, and in some cases that's me for my matrics, that's unluckily, I'm their examiner up until prelims. Now, the direction they can choose for you. You need to know how to work with direction. Remember that direction is one of those things that you've got to deal with as a vector. So you've got to choose a positive direction. Now, I'm just going to make you aware that sometimes choosing a positive direction is actually not that easy. The cool thing about it is you can always work with whatever positive direction you've chosen. Okay, so if you decide a particular direction is positive, you can actually work all the way through to the end, even if you didn't choose it very wisely. It's absolutely okay. There's no right and wrong in choosing a positive direction. I just want you to be absolutely sure that you know how to work with direction. This is one of those keys to the challenge question. Okay, so let's start taking a look at our solution here. Okay, now this next one is something that you're not always going to need, okay, but your table is a very, very good way to collect all your data. Now, your data might be sorry, I'm just making a bit of a mess there, okay? So your data might be a mass, it might be a velocity, it might be all sorts of things, but it's just a really nice way of collecting your information. Very often your questions are very long, there's a lot of complicated words. I want you to collect your information in a very nice, easy to see way, and a table is probably the best way to do that. Kinematics, a table is almost a must. You've got to go through sometimes your teacher will be talking about U, V, AT, and S. In kinematics, you can also do V initial, V final, your delta time, your acceleration, and your delta Y. But I'm going to be dealing with how to do a table in a moment. Okay, now this is the last step. I need to make sure that people actually understand what we're doing here. Now, if I actually make a bit of space, the very, very last step is the only one which actually usually gives you marks. The equation is where all the marks are. The problem is that people, because of that, actually jump straight to the equation. Now, unless you are absolutely amazing at remembering a million things, don't jump straight to your equation, because very often you're going to get something wrong. All of these steps are actually there to guarantee your success when you're dealing with physics. Now, some of them might be optional. The first one is not negotiable. Diagrams are a must. Choosing a direction is a must, because very often you're dealing with vector quantities. The only time that direction is not actually all that important is when we're dealing with conservation of energy, and that's a very, very tiny section. Even then, I decide, okay, well, I'm going to choose up or down as positive. Try not to choose negative directions, because it's very, very confusing. You know that if one direction is positive, the other one must be negative. So there's your 4 steps. Okay, diagram, direction, table, and equation. DDTE is one way to remember it. Okay, just those 4 letters can help you approach a lot of your physics questions. So draw yourself a diagram. It's not even an option. Choose your positive direction. Draw up a table to collect all your information, and then deal with your equation. Okay, now what is an approach without an example? So what I want you to do is, you're actually going to follow with us at home, and I'm going to ask Indy to post up question 1. So what's going to happen is question 1 is going to go up on the page. It's going to have 2 parts. There's question 1, look for 2 pictures. There's one with a graph, and then there's a set of 4 questions attached to question 1. I'm going to ask Indy to post those up on the page, and I actually want you to try this with us. Okay, so here it is. Let's actually start dealing with this. So the first graph, I'm going to post this up, and this is going up on your Facebook page. All right, well, I've got a graph, and there's some interesting information going on here. It tells me that an object is moving upwards when it leaves the hand of a thrower, and then I've got a graph of its motion afterwards. Now, it doesn't take a genius to figure out that this does not look like the way that a ball goes once it leaves your hand. Now, I've got to be very careful about this. We're dealing with graphs of motion, not pictures of motion. There's a very big difference. I need to describe the motion in terms of what's going on in this particular graph. My first job when I look at this is not to think of the ball going up and down and to start thinking of pictures. First of all, let's just figure out what is given in the question. So, first and foremost, let's try to figure out what graph we've got before we even start approaching this to draw a picture, decide on a positive direction, do a table, do an equation. Okay, that's all coming later. Let's just look at the question. This is the biggest problem that learners have got. I have got velocity, which is measured in meters per second there on my y-axis, and I've got time. So this is a velocity time graph. Okay, other important pieces of information that I get given. Here it is. Okay, well, I'm told that initially over there, there's 4.9 meters per second. Something happens, something happens, something happens, and it becomes 0, and then it carries on. But now there's not a lot of information given on the graph. There's just 2 times which are marked as t and t2. Now, my job is to try and figure out what's going on this velocity time graph. Okay? Well, I can start to get a lot of information about my picture just by studying my velocity time graph. Remember that vectors have got direction. I've got a region where my velocity was positive. Later on, I find that my velocity becomes negative. Now, this is something very interesting to note. Velocity time graphs are by far the most common. And one thing which is quite useful to know is that these are different directions. It tells me that an object is moving upwards. So this is an important piece of information to draw my picture from. So it tells me that the object is moving upwards. So that first velocity must be upwards. It then becomes 0. So something's happening in between there. This means that my entire first section is upwards. So I know that if the velocity is positive, that means that this whole thing is upwards. I can see that from my initial information. I was told that initially the object is moving upwards. There it is. There's my first velocity. It's telling me that upwards is positive. It's actually decided that up is positive. Now remember, I told you that you could choose plus and minus. Here the examiner has done it for you. Okay, so when it leaves the hand of a thrower. Now there's a whole bunch of information going on here. Let's take a look at the questions that it's going to ask us about this graph. Let's draw the picture together. Let's do the calculations later on. Okay, so let's look at those questions. First of all, they're asking me what the gradient of this graph is. Okay, now this is a particularly difficult question because, take a look. We haven't been given any information about the x values. How are you meant to calculate a gradient of a velocity time graph without some sort of picture inside your head? Okay, well, let's draw a picture. So what I'm going to do is we're going to draw what I see here. An object is moving upwards until this point. I find that at some point the velocity becomes 0, and that's the big clue. It changes direction, and we find that eventually it's going to be heading downwards. So now an object which is moving upwards and then moving downwards sounds to me like something which is going up, stopping, and then coming back down. So I've got an object which is moving upwards, its velocity is becoming 0, and then it's coming back down. So we've got two pieces of information. I'm being told that it goes up, stops, turns around, and comes back down. We're not sure how far up or far down. We'll figure it out as it goes. Okay, so the first piece of information is actually asking us, what is the gradient of this graph? Well, I've got my diagram, and it's been told that upwards is positive, so we've chosen my correct direction. The question is, how do we figure out what the gradient of this graph is without values? Remember that this VT graph is for an object which is moving up and down. I get that from my picture. So now, the only way that I can get the gradient of a VT graph is by knowing that the gradient of a VT graph is my acceleration. So now, I can actually see from the slope of my graph what the acceleration is. Now, how am I meant to guess this value without using x and y values? Now, for something moving up and down, this is something which I got from my diagram, I can actually figure out that up and down is usually controlled by the force which you're feeling right now, and that is gravity. What I'll actually find is that my gradient is negative 9.8. Where did I get this value? That is from the acceleration of gravity. Now, this is something very, very difficult. Now, I've chosen these very difficult questions because I've actually taken this from a past paper. It's asked me what the gradient of a graph is without giving you values to calculate it. So, obviously, I can't use the values. Okay. Now, knowing that my gradient of my graph is negative 9.8, that means that acceleration is 9.8 meters per second squared down towards the ground. I can start to calculate the other bits and pieces. Okay, so let's do exactly that. Calculate time t. Now, I need to start collecting my information. I've got some information. I've got a very vague idea of what's going on here, but I need to start taking a look at my graph very carefully. Time t happens when the velocity becomes 0. So what I'm going to do now is I'm going to draw another diagram. I'm always full of diagrams, and the diagrams are going to be your lifeline. So I'm going to answer question 2 now. So question 2, I'm going to go through these steps with you. Okay, well, I know that initially the object was heading upwards at 4.9 meters per second. That's the most important piece of information that we were given initially. The object is moving upwards, and what happens is it stops up at the top at 0 meters per second. That's quite an important piece of information as well. I was told the final velocity. Another important piece of information is we know that up has been decided as positive. See how useful my diagram is? I'm just collecting information. It doesn't have to be a work of art. I just need to put the relevant information on it. So I've got my diagram. I've got my direction. Let's make it a table. Okay? So our table, V initial, V final. Now some of you might be used to U and V. That's absolutely fine. You can use your values there. So V initial, V final, my change in time, which I'm looking for, acceleration, and delta Y. These are all the possible values that I can deal with. So now what is my V initial? I've been told that it's 4.9. My V final is 0. My time is something which I wish to have. And then my acceleration, something I've got to be very careful about. My acceleration was due to gravity. And unless we live somewhere very strange, acceleration is always down due to gravity. And down in this case is negative. I know that this is negative 9.8. And I can tell you now, this is where 80% of you are going to get this wrong. You didn't draw your diagrams, you didn't choose your positive direction, you didn't listen to your own choice or the examiner's choice. This little negative is going to cost you marks unless you pay attention to it. Absolutely vital. Now, the displacement, we're not told, and we're not asked it either. So what I'm going to do is I'm going to leave it out for the moment. Okay, so I've done step 1, 2, and 3 with you. Doing these 3 steps shouldn't take you longer than about a minute. Now, what I'm going to do is I'm going to select an equation, and this is the really beautiful thing about doing this approach. I now have got an equation where I've got to have v initial, v final, I've got to have a change in time, I've got to have an acceleration. Now what I can do is I can go look for one of the equations of motion. Now, I don't actually want you to go look for an equation with those 4 in, because that's going to take you a long time. The quickest way to do this is to find an equation which doesn't have delta y or delta x in it, one which doesn't have displacement inside it. So now it actually becomes a lot easier when I know that I'm looking for one without something. So you scan all the way through these, and what you'll actually find is that the easiest equation to do this with, and let's work in a slightly different color to show you the final step. This is where you're going to get your marks. Okay, so now let's write this in white so that you can actually follow this. Okay, so I've got my v initial, I've got my my final, I'm looking for delta t, and I've got my delta a. My a. Okay, let's put up our equation. All right, so Vf is equal to Vi plus A delta t. The reason that I've chosen this one, it doesn't have delta y in it. Let's put in my values. Let's find out what I've got. Okay, so now if I've got my Vf, that is 0. My initial velocity is positive 4.9 plus a negative value of 9.8. I change my time over there, and if I solve for this, what I'll find is that when I take over the 4.9 to the left-hand side, I've got negative 4.9 over there. That's equal to negative 9.8. And this is why that negative is going to cost you marks if you forget it, because otherwise your time wouldn't be positive. So time there is equal to 0.5 seconds. So the time that it takes to get up to its maximum height is half a second. Now, one of the ways that you can actually notice if you've messed up on any one of these steps, okay, and there's the entire thing up on the page. Don't worry, if you're furiously writing this down, we're going to post this up later on learnextra.co.za. What I want you to take note of is that in this calculation, if you try find one of 2 things, if you find that you've got a negative time, or if you're trying to find the square root of a negative number, one of these signs in your table has gone wrong. So if you guys are struggling with vertical equations of motion, please, please, please take note of your signs. Okay, so let's move onwards. Okay, I think we're close to a break point.
We are. Are
Okay.
you close to breaking point?
Okay, well, what I'm going to do is I'm going to set it up for the ad break, and then we're going to move on.
Cool.
Okay, now this next part. This next part is a particular problem because people don't know how to approach it. What I'm going to do is I'm going to ask you guys to work on this at home and try and figure out if you can't see how to get this. Now, I bet a whole bunch of you are going to come up with a quadratic equation. That's not how I want you to do this because otherwise the maths gets a little bit messy. I want you to find a way to find out what T2 is if the object falls 30 meters from its highest point. So let's just highlight the important information there. Let's just find out what is relevant. So it tells me that there's 30 meters from its highest point. That's a vital piece of information. It wants me to find out what T2 is. Okay, so let's just find out on my graph here. What information do I know? Well, now I'm starting to talk about from the highest point. Now, I'm going to make a little bit of a note, give you a little bit of a clue that you can actually find out where the highest point is. That point over there, 0 velocity, is where the highest point actually occurs. Okay, so that is the highest point. There we go. Let's cross our H's there. So that is the highest point. That is because velocity becomes 0. Okay, there we go. All right, so I want you guys to work on this. We're going to take a short ad break. I'm going to have a sip of water and then carry on bombarding you with physics information. What do you say, Indy?
I think that sounds like a fantastic idea. Okay, guys, grade 12s, this is your final year, so now is the time to put in the extra hard work. We know you can do it. Now you just need to know that you can do it yourselves. So let's take a little break, get those questions in on the page, and then, yeah, let's learn more. Let's learn extra. See you now. Hi guys, and welcome back to Learn Extra Live. It's grade 12 physics finally, and I know that you're all tuning in. I know because you're all going crazy on the page. Karshifa, I see you. You're always on the page. Michelle, Clive, all of you guys, hey. And I am seeing all of your questions. Please keep them coming. We will be going through them in the last 15 minutes of the show. That's Learn Extra, www.facebook.com/Learn Extra. And let's give the show back to Phil. Phil, take it away.
Thank you so much, Indy. So what we're going to be doing is carrying on with this question, and I realize that some of you might have not clearly heard earlier on where we actually got that gradient from. Okay, so now the very first question, what is the gradient of this graph? What I've got to remember, first of all, is that this is a velocity time graph, and that gradient on a velocity time graph is always that object acceleration. So that's something important. I just want to drive that home. The gradient of this, the gradient of any VT graph, is always going to be the acceleration. So now that's quite important. Now because this object is going upwards, it's under the influence of gravity, and gravity is giving us our acceleration. Okay, there it is. And gravity's acceleration is always going to be 9,8 towards the floor or towards the ground. It's absolutely vital that you understand that gravity is always going to have a direction of downwards. If that's negative or positive depends on your question. Okay, don't always say, okay, well, it's always negative 9.8, negative. Okay, the reason that it's negative or positive is because of the directions that you've actually chosen. So what I'm going to do is I'm actually going to work with this negative acceleration of 9.8 because down is negative in my question. The examiner, in other words, me in this case, has chosen down as negative. So let's actually work with this. Let's try and discuss part 3. Let's see. If the object falls 30 meters from its highest point, calculate the second time. Okay, now that time 2. This was a particularly difficult one because very often people are actually going to reach for their table and they're going to find problems. Okay, so let's take it step by step. Let's do all our steps together and let's find out where we get from there. Okay, always, diagram and direction, those are your first two. So it says from your highest point. So now something very special happens at an object's highest point. I want to make sure that people remember this. When something gets up to its highest point, it actually stops and starts coming back down. That means that it starts out again at a velocity of 0 meters per second. That's right up at the top of this object's motion. Then what happens? As it starts to fall, it's going to fall down to the ground. Lucky for us, the examiner, which is me, has actually told us how far it's gone. It's gone from the top right down to the ground, and that's taken 30 meters to happen. Okay, now a lot of you are saying, okay, that's not enough information. Okay, I've got problems here. Okay, now what I want to do is I actually want to work through this, make sure that people understand that you keep the same positive direction, you keep the same approach. So there is a diagram, some pieces of information missing, we're going to figure out what's going on. Okay, draw in your positive reference. In this question, they want us to make sure that we're working with a positive upwards direction. Now, diagram direction, D, D, now we're going to do T. So the table, V initial, V final, acceleration. Well, let's actually make sure that we keep it exactly the same. Let's not confuse anyone at home. Let's make sure that we keep this in the same order. So VV, TA, Y. Okay, VV-T, that's what some of my learners in my grade 12 class like saying when we do this table. So VV-T. All right, so let's find out what VV, TA, and Y are. So the initial velocity, what velocity does it start the fall at? I can see that it starts at 0 meters per second. How fast does it end up hitting the ground? Don't know, don't care. We weren't asked it and we weren't told it. So let's just make sure that you're actually not looking for an equation with VF. Now, one of the things that I'm actually going to do is I'm going to show you a way around this. I'm going to show you where you're going to get stuck and then I'm going to show you how to fix it. Okay, now the time. The time is the question mark in this one. Okay, acceleration, we've got negative 9.8. Okay, please remember that downwards was negative. The final displacement, now a lot of people are going to say, oh, okay, fine, it's 30 meters. Don't forget that it's going downwards. So that is a negative 30. Okay, now if I go forth and find the equation without VF, we're going to run into a problem pretty quickly. I'm sure that you're going to actually find that the only equation which doesn't have velocity final is actually the one that's going to return us with a bit of a problem. Okay, now in this particular equation, it's not too bad. Okay, I'm going to show you why it can be a problem. I'm going to show you how to work around it. Now, if I actually pull that equation up, so delta y is equal to v initial delta t plus a half times a delta t squared. There we go. Nice and complicated. Now, I'm sure that you'll actually see that t appears in two places in that formula. Lucky for us, in this particular example, v initial was actually 0. So what's going to happen is that t is actually going to fall away. Lucky for us. So I've got a velocity of 0 times by delta t plus a half times negative 9.8. There it is. Okay, and then delta t squared. Okay, only thing to put in there is my displacement, and that was minus 30. It's going down 30 meters. Okay, so let's figure this all out. Let's find out what t is. And what I'm actually going to do is I'm going to show you how to work with this on your calculator. I'm going to work alongside you, and we're actually going to find this together. So there's negative 30 over there. Okay, and now I've got negative 9.8 times by half, which will get me negative 4.9, and delta t squared. Okay, so the first thing which I need to do is divide both sides by negative 4.9. So let's bring up our calculator. Let's work with each other. Okay, so I've got negative 30 divided by, and you've got to make sure that you're actually dividing by a whole negative number. So what you can actually do is push that button over there, and that changes the sign of what you're dividing by. Some people have asked me how to do that. Okay, otherwise you can actually just put it inside some brackets. So then we go 4.9 over there, and we should come out with an answer, lucky for us, 6,12. Okay, but now that is not time. Okay, this is time squared. Now, a good indication that we've actually done something right is that this is a positive number, because remember that you can't find the square root of a negative number. If we didn't put in that negative, we'd be in a lot of trouble. You can't find the square root of a negative number. And please, please don't be tempted to just go, okay, it's got to be negative, and I've got to change this in my answer. You're getting marks for these initial steps. You're getting marks for putting the negatives in the right places. Now, you've got to know your negative from your positive. Okay, so now all that's left to do is to square root my answer. And to save you guys a little bit of time, I want to show you a trick on the calculator. What I'm going to do is I'm going to push my square root button. Okay, and a lot of you already know this. There's actually an answer button down at the bottom here, which has kept your previous answer. So I'm going to put that in there, over there. And our wonderful Casio calculator is going to give us an answer, there we go, of 2,47. And that is seconds. So 2,47 seconds, fantastic. Let's write that in, but we're not done yet. Now, when I did set this in as a question, as 2,47 seconds, now that is not the final answer. I know the time taken for it to fall all the way down is 2,47 seconds, but that's not time 2. Please, please, please be very, very careful. That is the time taken for it to fall from its maximum height right to time 2. Just remember that there's actually 2 parts to this motion. What I've done is I found that that was equal to 2,47 seconds. But I need to make sure that I add in that initial little bit over there. That initial little bit, we actually calculated to be half a second. There we go. So 0.5 seconds, 0.47 seconds, they are together to give me time 2. And that's actually an extra mark in this question. It's actually to know that I've got to add t and this time over here, which we've calculated. So therefore, let's make my conclusion. T2 is equal to a half a second from our first question, plus 4.47 seconds. If you add that all up, I get 2,97 seconds altogether. That's how long this whole motion has taken. Okay, so very, very important that you're working with your signs, that you're finding a positive time, that you're finding the square root of positive numbers, good indications that you're actually doing something right. Okay, now the very last little bit, I know that it's quite a lengthy question. Okay, from what height was the object thrown? Now this is a particular problem. Okay, people really, really struggle with this. Now a lot of people say, okay, well I was told in the previous question it fell down 30 meters. Okay, but now there's a few tricks and a few ways that you can actually do this. One of the things which I can do is if I'm given the final values here, you could actually go and figure out the area underneath these two triangles. I find the area going upwards and I find the area going downwards and subtract them. But I wasn't given any values over there, and that's a bit of a pain. So what I've got to do is I've got to go back to the drawing board and draw, choose my positive direction, make a table, go through the whole thing again, and try and see if I can't sort this out. Okay, now there's two options. When I've got an up and a down motion over there, so there's an up motion over there, going up to that highest point, coming back down. We know that the coming back down is 30 meters. That's pretty useful to know. What if I find out how far it went up, the maximum height? That's not too difficult to actually do. So what we're going to do is I'm going to figure out how high it went up and then subtract how far it went down, and we can find out where it is right at the end. Okay, so let's find out how far it went up. Choose your positive direction once more. In this case, it was chosen for us. We're going to make our table, and we're going to find out what's going on here. It was moving at 4.9 meters per second. Upwards, it finished at 0 meters per second, up at the top. We know that the acceleration is negative 9.8. There's our three pieces of information, which is the minimum. Okay, let's make a table of all this interesting information. Okay, so VVT comes out. Here we go. VF, TA, and Y. There we go. So let's figure out what's going on here. What information have I got? The initial velocity, 4.9. Final velocity is 0. Time, you could actually use that there's 0.5, but I'm actually not going to use time. The reason that I'm not going to use time is because time could be wrong. I think it's half a second. I calculated that it's half a second. And because I did the memo, I know that it's a half a second. But here's the problem. Okay, I'm not going to use time in this case because it's a calculated value. I do know that the acceleration is negative. Sorry, let's just make sure that that's nice and neat so you can read it at home and later on in the notes. Okay, so negative 4, no, wrong number, 9.8. There we go. So 9.8 over there. Let's find out what the displacement is. So we're looking for an equation without time. Not because we weren't asked time and we don't know time, but because we don't trust our own calculations, okay? And even if you're very confident, please be careful about this, okay? Everybody makes mistakes. I sometimes make mistakes. The only thing which changes is we get better at figuring out when we're making the mistakes. Okay, so let's find an equation without time and let's find out what the displacement actually is. Okay, now the only equation which has got that, so v squared is equal to v initial squared plus 2 times a delta y. So now let's do that together. Okay, so the final velocity squared, luckily for us, is 0 squared. V initial squared, 4.9 squared. There it is. And you're probably wondering, where is the negative going to come from? Acceleration's on its way. So there we go. Negative 9.8 goes in there. And we're going to get our displacement out of there. Let's just manipulate this to get us the correct way to do this. So there's 4.9 squared is equal to, and strange enough, you're actually going to find something very cool here. So 2 times 9.8 gets us 19.6 over there, and delta y over there. Now let's actually go and find out what's going on. So we're looking for 4.9 squared, negative, and that was negative. Sorry, I've been very naughty there. I've got to put in my negative to make this complete. Okay, so I hear you guys at home screaming, there's got to be a negative. There it is. Okay, so negative 4.9 squared. Now what I'm going to do is divide both sides. Remember that trick I showed you to make something negative without the brackets is to use this little negative button here in the brackets. Okay, so negative 19.6. There comes out our answer. Fantastic, it's going to go up 1,225 meters. Okay, So now that's, again, not our answer. 1,225 meters. That's not the final answer. That just tells me how far it went upwards. Just remember that these are vector quantities, and it's a good idea, and in fact vital, that you actually put directions on the end of these. Okay, so now I know that this object went a certain direction upwards, 1,225 upwards, but 30 downwards. So what you can actually do is now subtract them. So I know that it went 30 down, but 1,225 up. Let's see what happens there. So let's say it went 30 in one direction minus the other direction. I know that its final displacement over there is going to be 28,775 downwards. So there we go. So there's my final displacement, and that's my total, is equal to 28.775 meters down. So that is my total answer, and that is what they are looking for. Okay, very, very challenging question. I hope you guys managed to follow that at home. Are there questions about that?
There are a few.
Okay.
Can you take a few?
Well, let's devote 1 or 2 minutes to it, and then we've got to move on with some momentum.
Okay, exactly, because we don't want to spend too much time. Let me have a look here. Oh, gosh. It's always, what if VI was not 0? Does this mean we would deal with 2 delta TS? Did I even ask that
2
right?
delta T's. Okay,
Yeah,
what
yeah.
if V initial was not 0?
Yes.
Okay, I think they're referring to part 3. Okay, so now what happens if we've got, let me just bring it up there. I think this is part 3. There we go. Okay, all right, very, very good question. Okay, what happens if, there we go. This is what they're talking about. What happens if V initial is actually not 0? Okay, then you're going to run into a bit of a problem with this, because all of a sudden now, this term doesn't disappear anymore. And that means that you've actually got to solve this using a quadratic equation, which is very, very, very messy. So actually what I want you to do is to work around it. You can work smart, okay? Now what you can actually do to help yourself is actually to remove this cross and actually go and calculate the final velocity. So actually go find the final velocity, and you're going to break one of your own rules, but it's actually to save you a huge amount of effort. Find the final velocity and then use that, because that allows you to use other equations to find time, to find your time, and it's not going to be this messy quadratic mess. Okay, please, because this equation can give you endless headaches. You're going to find 2 t's all over the place. You've got to factorize, but you can't factorize. And then you've got to use a quadratic equation. You can't remember if it's minus b plus or minus square root. Okay, don't even do it to yourself. Save yourself a lot of effort. If you've got an equation like this for t, which gives you a quadratic, rather stop. Find your VF and use that. Otherwise, you're going to run into a huge, huge, huge amount of trouble. Okay, I hope that answers that question.
I think it does. Okay, one more question, and then you can carry on full, I promise.
Sure.
Okay, so this one is from Fortune, so great. And he says, can you just explain to me how our displacement is negative? I don't understand that part. Why is it not positive? Do we measure it from the top or from the ground?
Okay, now your displacement is always measured from your starting point. Now, whether or not that's from the highest point or from where it's thrown, I've got to realize what's going on here. And this is why the direction is so important, and why the diagram as well. Okay, so I'm going to redraw the flight of this object. Now, one of the things that I'm going to do with my object is that my object is going to go up and then fall down. Okay, I know that from the top down to the bottom, this is 30 meters. Now, if you remember inside your question, you were actually shown on your graph that the initial velocity was positive and the object was being thrown upwards. So I know, regardless of what the ball is doing or what this object is, I know that up is positive. Now, when the object is falling, like in example 2 and example 3, what we'll actually notice is that the object is going downwards 30 meters. So from the beginning to its end point, I'm finding that it's going 30 meters directly downwards. And remember that down is the opposite of up, and that means that down is going to be a negative direction. So it's going to be negative 30. And you'll find out very, very quickly from your substitution whether or not things have gone right, because you've got to have that negative in there. So now if I go back to the working out there with the negative 30, there we go. Okay, so that negative 30 was absolutely vital, because otherwise I actually would have found a time from a square root of a negative number, and that's absolutely impossible. Your maths teachers will jump up and down on you if you try to do that. Okay, so now I needed that negative 30 to cancel out with that negative to make sure that my time comes out positive and that I don't have to square root a negative number. Those are your two signs that you've actually messed up the plus and the minus. So if you come out with a negative time, or you're trying to find the square root of a negative number, that's a problem. That means that you've messed up somewhere inside your table. This negative 30 was because the object was moving down, and down is negative. I think we're going to take a short ad break.
That's exactly what we're going to do, Phil. We're going to give you a bit of a break. Guys, grade 12s, don't you dare leave. This show is especially for you. And before we do go, I just wanted to let you know about winter school. I'm sure you saw Ty's little ad before the show started. I know a whole bunch of you are super, super excited about this. It's going to be from the 2nd of July until the 6th of July, from 9 a.m. in the morning to 6 p.m. in the evening. And this is especially for you grade 12s mindsets. As grade 11s and grade 10s have their own shows, but this week is dedicated to you. And not only are we doing the maths, the physics, and all of the usual subjects, but we are also doing English, geography, and accounting. And I know there's a whole bunch of you that have been shouting out for that. So let's take a break, and we'll see you now. Hi guys, and welcome back to the last section of Learn Extra Live Physical Science Grade 12. And I know that you all have been hanging on to the edges, or the edge of your seats, and you're learning lots, and you're learning more, and you're learning extra. And before we start, I just want to give Liberty a big shout out. Thank you guys for making such an awesome show. You rock. We love Learn Extra Live. And before we carry on, we've also got this fancy labeler that we are giving away to one of the best posts, and that's the best post throughout grade 10, 11, and 12. What you have to do is just need to help each other out on the page, be a mindsetter, always be inspirational, always be positive, and always wanting to learn more and to learn extra. And without further ado, we're going to go back to Phil. There is a lot to work through, but he has a solution. So Phil, take it away.
Okay, guys, we are running short in today's lesson because you guys have got such amazing questions. What I'm actually going to do is I'm going to post the remaining momentum question, the remaining mechanics question actually online. And we're going to post up these questions, and I'm actually going to jump on Facebook a little bit later and actually answer your questions. Okay, so what I'm going to do is I'm going to run you through this question very, very carefully and very quickly and get Indy to post that up. But then we've got to get back to our challenge question and make sure that people actually understand.
Exactly.
Okay, so just running you through this very, very quick mechanics question. I like this one because it's got change in momentum, it's got impulse, in other words, and it's got the conservation of momentum. So two very difficult topics, and we're going to be dealing with this. Okay, so now I've got a ball which is heading towards a racket. This ball has got a mass of 57 grams. It's very, very small. Let's make it nice and big. Okay, so that means that this ball is traveling at a mass of 57 grams, and it's got a velocity of 30 meters per second towards the racket. Now there's a racket headed towards it, which has a mass of 300 grams. That's slightly more visible. Let's just make it nice and big so that everybody can see what's going on there. Okay, so now there's two objects headed towards each other. This should go ding, ding, ding. We're actually dealing with a collision, and a collision is always something to do with momentum. Okay, so you should be starting to think about change in momentum, conservation of momentum. Now, those are not concepts which disagree with each other. It's just when I take a look at one object or both objects together. Okay, now by it I mean the ball, undergoes an impulse of 2.85 Newton seconds while in contact with the racket. Okay, so there it is. There is a picture. I'm asking Indy to post this up online. You guys can discuss it, solve it, and deal with any questions to do with it. Now, what I'm going to do, and I'm actually going to ask you for a little bit of forgiveness. I've actually made a numbering error. It seems that I can't count. I'm so glad I'm not a teacher, hey? Okay, now, I've actually put number 3 twice because I like number 3 so much. Okay, but it's actually question 4. Okay, now there's 4 particular questions over here. Now, the first one actually deals with the magnitude and direction in the change of momentum of the ball. I want you guys to discuss that and to try see if you can't actually understand there. Just make the correction, because we've actually posted it up that there is 2 number 3s, and that's not correct. Okay, that is actually a number 4 there. Okay, so what is the magnitude and direction and momentum of this ball? Okay, let's deal with that. Okay, calculate the ball's final velocity after the collision with the racket. Okay, that's quite a difficult question. Just a bit of a hint. From question 2 onwards, actually right from the beginning, choose your positive direction. Draw your own little diagram, even if you can't draw a tennis racket, even if you draw something ridiculous that looks like something that you use on potatoes. Okay? Draw your picture, please, please, please. Okay, I'm begging you, because this picture and the direction are actually the most vital part of this. You're actually going to find without direction, you're getting an answer which kind of looks okay, but it's not. Okay, diagram and direction are absolutely vital, because we're dealing with momentum. Momentum is all about the direction. Okay, so now that was one of the clues towards our challenge question. I'm pretty sure that people are answering the challenge question quite nicely.
Yeah, we've got lots of answers.
Okay, all right. Calculate the force experienced by the ball. In other words, while it's in contact with that racket, you've got to figure out how hard this racket is actually striking the ball. And then for the last question, is calculate the velocity of the racket as it hits the ball. Okay, so the velocity of the racket as it hits the ball. So I want to find out how hard does this person have to swing this racket, in other words, to get the ball to return at whatever velocity it does in question 2. Super, super hard question. What I'm going to do is I'm going to let you guys solve and discuss and play around with this question. I'm sure that you guys are studying nice and hard. And what I'm going to do is a little bit later on tonight, around about 9 o'clock, I'm actually going to do my homework, jump online and actually answer some of your questions there directly underneath the question. Okay, so work through these questions. Please help each other. Decide your positive direction, first of all. Just remember that everyone's going to choose a different direction, and there isn't a wrong positive direction. You just got to work with what you've got. So let's just set this up quickly before we get to that challenge question and put everyone out of their misery. Okay, so now, even though I've got a nice picture, what I'm going to do is I'm going to draw my own tennis ball, and we're going to draw our own racket, and you're going to see what a terrible artist I am. I can't count and I can't draw. So there we go. So we've got our tennis racket. There we go. Fantastic. And it's going to be swinging towards the ball. Now, it's absolutely vital that you know what's going on. So this is a picture of before the collision. Now, I was told that initially that this ball is headed there at 30 meters per second. The racket is headed at an unknown velocity. We're not entirely sure. Okay? So that's some information which I need to know. Once again, let's just summarize the information about the mass. Cool, I've got the mass and I've got the velocity of one of the objects. Very important. I'm told that the mass of the racket, so this is mass 2, is 300 grams. And we're nearly done with the first 2 steps. So here's my diagram. What we've got to choose is a positive direction. Now, just something very interesting to note is that it doesn't actually matter which direction is positive. I'm going to choose the original direction of the ball as positive. You guys don't have to. That just means that the initial velocity of the ball is positive. Now, what I want you to do is I want you to work through this, substitute your values. Something else which you need to take note of is that my grams has got to change. The grams have got to change. Absolutely vital. There we go. Grams have got to change. Now, some of you might not have noticed that I've actually got to change grams into kilograms. Anytime you're working with maths, you should know this from grade 10, that that has to change into kilograms. So there we go. That's going to be 0.3 kilograms. And over there, we're going to get 0.059 kilograms. Absolutely vital that you're working with those. Okay, we've got a positive direction. We converted our masses. We know what velocity is. The only thing which we need to start doing now is find out what information I've got and actually deal with an equation. I'm going to let you guys do that. I'm going to do my homework with you guys and discuss the question with you guys online. So I'm hoping that you're up later. The wonderful thing about Facebook is it never goes away. Okay.
It's always on.
Absolutely. Okay.
The nice thing, but the terrible thing as well.
It's a terrible thing. Okay. So if you guys are Facebooking in class, please stop. Okay. So what we're going to do is we're going to go through that challenge question. We are going to put people out of their misery and find out what's going on. Okay. So now what I'm going to do is I'm going to tell you why the correct answer is what it is, but we're going to keep you in suspense just a little bit longer, and we're going to find out what's going on. So now, what happened was before the collision was we had this tank, and this tank was rolling forwards. So here's our tank, and our tank has got a gun which is shooting out a bullet. Now, our tank had our mass of 2,000 kilograms, and I was shooting out another object. See how I'm drawing all my objects, and I'm collecting all the information. And the bullet over there, the bullet is coming out at a very, very high velocity. So you'll notice that in every calculation where you're dealing with the velocity of a bullet, it's coming out at a very high velocity. So that is 600 meters per second. Okay, I've got the mass and the velocity. I've also got the initial velocity of the tank. That's something a lot of people didn't actually take into account. The tank is rolling forward at 1 meter per second. Okay, so that's an important piece of information. Okay, now, if you take a look at what's going on here, both of them have got momentum in one direction, so it seems to me a very good idea to choose that as a positive direction. What you'll notice if you run through all of your calculations is that the velocity of my tank, let's call it velocity 2, and we're going to call that the initial velocity, which is 1 meter per second. Let's actually put that somewhere neat. Okay, so velocity 2, initial velocity, was 1 meter per second. That was a positive number. It's going to come out to be a slightly different number, and I want you guys to reinterpret. So velocity to final is actually going to come out to be a slightly smaller number. It's actually going to be kicked backwards at negative 2 meters per second. So here we go. Our correct answer today is B, 2 meters per second backwards. I want you guys to discuss that. First person to answer with a correct explanation of the directions. I've actually got to make sure that people are explaining this properly, okay? It's for yourselves, it's for other people as well. Okay, I want to discuss why the other answers are not correct. Okay, the same as it is a much larger object. Now, one of the things that does not take into account is because this bullet is coming out with such a large velocity, it's got a huge amount of momentum. That momentum has to be conserved. So that means that any momentum that the object being pushed out goes forward. So in other words, that momentum that the tank shell gains in the forward direction, the tank is actually going to gain in the opposite direction. Okay? Forwards was wrong because of the wrong direction, and then 0 meters per second was entirely wrong because the tank does not stop. I hope that people answered this question. I'm sure there's a lot of discussion going on, but I think that's all we've got time for.
That's all we've got time for, guys. I think my producer, how much time do we have? We've got exactly 20 seconds. That gives me 20 seconds to say goodbye to you all. Thank you so much for tuning in, guys. Phil will be going onto the page and we'll be answering a few questions for you guys. So please make sure that you make them short and you make them sweet and you make them easy to understand. Thank you, Mindsetters, grade 11s, grade 12s for learning more, learning extra. Grade 12s, you rock. See you same time, same place next week. Bye.